Let's start with the first problem. And my screen is visible, right?
Yes.
Okay. So this is the first problem of today's contest. And in this problem, we are given that a prime number, we all know like what is a prime number, right? It is a number which is more than one and which has only two divisors, one and the number itself. Now, we are given a sequence of digits from 1 to 9, which every digit from 1 to 9 appears exactly once. So each of these is appearing once. Now, what we need to do, we are allowed to do the following operations several times, maybe 0 or more. Now we'll choose any digits from the sequence and delete it. So we cannot do this after we have like less, we have two digits left. Like we cannot make uh, one digit in our finals, like in our string after some operations. We cannot do these operations after we have two digits left. So we finally want a prime number, like the string, this number which is left. Like let's suppose we started with this. So finally we should have a prime number. And when we are applying these operations, we cannot change the order of the digits. So let me know in the chat how many people were able to solve this problem during the contest. Okay. So this problem is really simple. See, you can see 13 is a prime, 31 is a prime, 17 is a prime, and 71 is also a prime. So like this, you can pick up either this thing or this thing. See, if position of 1 is before 3, or if position of 3, like either this will be true, position of 1 will be before 3, or position of 3 will be before 1. So either you can print one of these, or like you can do it like this also. And you can, like there are many, 73 and 37. So you can use these also. So I'll show you the implementation, okay? So during the contest, I have used 17 and 71. So I have just found what is the position of these two characters. So let's say X is the position of 7 and Y is the position of 1. So if X is before Y, I'll print 71. Otherwise, I'll print 17. So let's go to the second problem. Is anyone having any doubt in this first problem? No, right? This thing is clear. Okay. So let's go to the second problem. So in this problem, we are given that two strings A and B of equal length consisting of only characters 0 and or 1, both start with character 0 and end with character 1. Now we want to make, now in one operation, we can do the following. We can choose one of the strings and two equal characters in it, and then turn all the characters between these two into those characters. So I'll explain what this means in a moment. But finally, we need to determine if it's possible to make the given strings equal after applying these operations. Okay. So I think, okay, I'll explain you the problem statement here. See, if you are given a string like something like 1 0 0 0 0 1. So see, these two characters are same, right? So between these two characters, we can make everything as 1. So this is the basically the operations that is mentioned in the problem. So we need to choose one operation, one of the strings and the two equal characters in it, and then turn every character between those two equals to those two characters which were equal. So finally, we want to know whether the two given strings to us can be equal or not. See, starting of both of these is 0 and the ending is 1. So in this problem, you just have to check whether after at some position I and I plus 1, you're getting some zeros at this point and ones at this point. If you're getting this configuration in between for each of like both of these strings, then the answer is yes. You can always make these two strings equal. How? You'll first make for the first string, you'll make everything 0 here, and here you'll make everything 1, and same way here. Is it clear? Yes, no?
Yes.
Okay. Is anyone having any doubt in this, by the ways? Okay. So I'll show you the implementation. And is my voice breaking? Like, can anyone just write in the chat?
No.
Okay. So first I have taken two strings as input, then this f is basically whether or not I'm getting that configuration in between or not. So how am I checking it? If ai and bi are both same and they are equals to 0. So instead of doing this, I could have also done something like if b of I is equals to 0, like this is also same, right? If both of these characters at this position are 0 and both of these characters at these positions are equals to 1, then my f is going to be 1. So after all of these all of these iterations, if my f is 1, then my answer is yes, otherwise it's no. Is it clear?
Yeah.
Okay, so let's go to the next problem. So coming to the next problem, we are given that monocarp had an array A consisting of integers. Now initially this array was empty and monocarp performed three types of queries to this array. He first chose like it isn't first, but like these are the three operations. He can do this in any order, but one of the operations is he chose an integer and appended it to the end of the array. Now each time monocarp performed this query, he wrote a character plus. Then the second operation is of type he removed the last element from the array, and each time monocarp performed this type of query, he wrote out a character that is minus, and monocarp never performed this query on an empty array. See, if there are 0 elements right now in his array, he won't perform this minus operation. So now the third operation is he checked if the array is sorted in non-decreasing order. That means in increasing order. And this k is nothing but the total number of elements that are at that instant in the array. So then if the array is sorted, he'll write 1, otherwise he'll write 0. And you'll have to, like, if the elements in the array are less than 2, then the array is considered to be sorted. So this means less than 2 means, what does less than 2 means? So your elements in an array can be either 1 or 0. For 0 also, it means that, okay, it's sorted. But actually, I don't think like it will ever happen. You will only get maybe like it can happen. I don't know. Maybe you'll get a wrong answer if you're not considering that case. If you have 0 characters, then it's considered sorted. So now what we are given these characters that he had written 1, 0, plus, and minus, and we have to find whether they actually like whether it's consistent or not, like the sequence is consistent or not, whether monocarp could actually perform those queries, like perform some queries so that he would have received that sequence of characters. So basically, let me take some of the test cases from here. Let's take these. Okay, let's take these 5 test cases in it, for example. Okay, so the first case is plus plus 1. So this means you first added a character, then you again added a character, and then you find that the array is sorted. So this is possible, right? 1, 2, and this is sorted. So the answer is yes. But let's look at this case, plus 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 1 minus minus 0. So you added a character, you added a character, you added a character, you said, you checked, you saw that the array is sorted. So you found, okay, the array is sorted. Then you removed this character, then you removed this character. So now you are having one character, and you again checked whether your array is sorted or not. And you said the array is not sorted. But as you have already seen, if the array is having elements less than 2, then the array is always considered to be sorted. So that's why this is not possible. So that's why the answer is no. Is this thing clear? Why the answer is yes here and why the answer is no here? Okay. So now let's look at plus 0 also. So why is this not possible? Again, you're having one element in your array and you're saying that it's not sorted. So that's why the answer is no. So again, let's look at this 0. So okay, this is that test case when you're having no elements in your array and you're saying it's not sorted. So you should say that this is sorted, because if you're having 0 or 1 elements in your array, then your answer is yes. Now coming to this test case, let's look at this test case also. Plus 0 minus plus 1 minus plus 0. So is this possible or not? See, after these 2 points, you said the array was not sorted. So let's take the example as 2, 1. Then you removed the last element, you removed this thing. Then you added another element. So let's say you added 3. Now you are saying it's sorted. Yes, this is sorted. Then you removed one element. So now you have 2. You removed this. You added one more element. You added 1. You are saying it's not sorted. So this is also possible. So the answer is yes. So now how to actually solve this? See what I'm doing. I'm only like at this position, I'm only checking. See, along with my string, I'll maintain a vector of size n. Vector of size n. And let me tell you what this vector will give me. See, if the vector initially everything in this vector will be 0 only. So 0 means if v of I is 0, that means I don't know whether at this point my vector is completely sorted or whether it's not sorted. Like I cannot say anything by 100% surety. But if I find that v of I is 1, then this is basically that the array is sorted at this point, right? And if v of I is -1, then I can surely say that the array is not sorted at this point. So first of all, is these three things clear to everyone? Like there is nothing. These three other, like you can treat them as nomenclature for this thing. So I'll, along with my, see my string s is of size n. Along with this, I'll maintain a vector of size n, and v of I is 0. So I don't know for sure whether it's sorted or not sorted. Okay. So it can be anything at this point if v of I is 0. If v of I is 1, then I definitely know that for up till this point, the array is completely sorted, the elements that are in the array. Otherwise, if v of I is -1, then I know that the first I elements are not sorted. Is it clear now? Yes, no, anything? Okay. So now how to okay, other than this, now how to use these things? See, if v of I is 1, can anyone tell me, like this means that the all the elements up till like 0, 0th element, first element, all the way up till ith element are sorted, right? This means this thing. So now, what will be v of I -1? Can anyone tell me? Will it be 1? Will it be 0? Or will it be -1? If v of I is 1.
0.
Why?
Because
1.
it can be sorted or unsorted both.
How it can be sorted and unsorted? If v of I is 1, I have something like 1, 2, 3, 4, 5. If this thing is sorted, how can this thing not be sorted?
Oh, okay. It's I -1. So it will be sorted.
Okay. So this thing is clear to everyone that this thing will be 1 only. Now, v of I plus 1, I don't know what v of I plus 1 can be. So this will be 0. But now let's look at if v of I is -1, then what will be v of I plus 1?
-1.
Yes, because if it is not sorted until now, how can it be sorted if I add one more element to it? So we only need these things. And v, by the way, v of I can be anything here. I'm not worried about v of I minus 1. V of I minus 1, like it will be 0. Like I don't know what it can be by simply looking at this. So my point is, see, when you're getting an element, let's say you're getting a plus. So first you'll check if your last element of v, if that is, let's call this last element v dot back. If this is equals to -1, so then your array is still unsorted. So in v, you will push back -1 only. If otherwise, if your back is not -1, then you'll push back v dot push back 0, because you don't know whether it's sorted or not. So this is for plus case. When you're getting a minus, then what you'll check if v dot back was initially v dot back was equals to 1. So that meant your array was sorted. So first you will remove pop back. You will remove the last element, and then you will make your back now equals to 1 because it's still sorted. Otherwise, if this is not true, you will simply pop back. Okay. So this is like we have covered the two cases. Is anyone having any doubt in these two cases? When I'm having plus and when I'm having minus? You can unmute yourself and let me know. Is anyone having any doubt? Okay. So let's consider the case when we get either 1 or 0. So other than this, now this is the case when I'm getting 1. So this means that the array up till now should be sorted. But if the currently v dot size, like the number of elements that I have, is less than 2, I can simply continue. It's sorted, right? There is nothing to check. Otherwise, I'll check if v dot back, the last element, is equals to -1, then the answer is no here. Like right now, I can tell the answer is no. Why? Because this thing tells me that the array is sorted at this point. It's giving me, but if I look at v, I have the array is not sorted, right? Another thing, if otherwise, if this thing is not true, if v dot back is not equals to -1, then there are two cases. Either v dot back is 0 or either v dot back is 1. So in any of those cases, I can simply do v dot back is equals to 1. I can make it 1 because now, if earlier it was 0, now it will be 1. Why? Because I definitely know that up till this point, the array is sorted. Similarly for 0 case, what to do for 0 case? If v dot size is less than 2, then my answer will be no. Why? Because the array is sorted and monocarp is telling that the array is not sorted. Otherwise, if v dot back is equals to 1, that means the array was sorted and monocarp is telling it's not sorted. Then again, the answer is no. Otherwise, I'll make v dot back equals to -1. Is it clear? Finally, I can check if I have got no as in between, then the answer is no. Otherwise, it is yes. Is it clear? Yes, no, anything? If any, like, okay, yes is okay. I'm seeing yeses in the chat, but
Can you show the previous slide once?
okay, how to decrease the size of this? I'll show the complete thing. See, I'll quickly go through the complete idea once. If I am getting a plus, then first I'll check if the v dot back is having the last element was telling me that the array is not sorted till now. So now the array is still not sorted. So I'll add -1 at the back of my vector. Otherwise, if this is not true, then I'll push simply 0. That means I don't know whether it's sorted or not sorted. So this is the case for plus. So when I have to remove an element, I'll check if the last element was already sorted. If the last element was telling me that it is sorted, then I'll remove it and I'll make the previous element, like the last to last element, 1. Why? Because it's also sorted. If this is not true, I'll simply remove the element. Now coming to when I'm getting 1 and zeros. So if I get 1, I'll first check if the size is less than 2, I'll simply continue because there is nothing to check. There are less than 2 elements and the array is sorted. Yes, it is sorted. So simply continue. But if you're getting that the array is sorted and the last element is telling you that it's not sorted, then your answer is no. Otherwise, make your last element sorted. Like make it 1. Otherwise, if you get 0 in input, then check if v dot size is less than 2. If it is less than 2, technically your array should be sorted. Like it will be considered as sorted. But here you're like monocarp is telling that it was not sorted. So your answer is no. If v dot back is 1, so this is telling you that it's sorted, but monocarp is telling you that it's not sorted. So again, your answer is no. Otherwise, make it unsorted. Like at this point, make it -1. So is it clear?
So the vector v, it first consists only 0.
It consists of 3 values, either 0, 1, or -1. 0 means that at this point, I don't know, like we will have something like 0, 0, 0, 1, 1, -1. So at this point, I definitely know that the array is sorted. At this point, I know that the array is definitely sorted. At this point, I definitely know that the array is not sorted. So if I add anything at the back of this, if I try to add anything at the back of this, the array will remain unsorted, right? But if I try to remove all of these elements one by one, once I remove this one, I'll make this one. Why? Because if this complete thing was sorted, this thing is also sorted, right? So I'll make 0, 0, 1 when I remove this element. Is it clear? But if I try to add elements at the back of this, they'll remain unsorted only. So I will have something like this. So my vector is having 3 values, 0, 1, and -1. Is it clear?
Yes.
Please, can you explain that point? Like when it is 0, 0, 1, 1, like when it is the third case when we encounter the 1. So you are saying that v dot back equals to -1, then it is it's no.
Yes.
But you are saying then v dot back equals to 1. So can you explain this point?
Okay, if v dot back is -1, that means that at this point you already knew that the array is not sorted. So if it is not sorted, how can monocarp tell you that it is sorted? So that's why answer is no. So if this is not true, then there are 2 possibilities. Either your v dot back is 0 or it is 1. So if it is 0, you don't know actually whether it was sorted or not sorted initially. If it is already 1, then you already know that it was sorted. So it doesn't change anything. But if it is 0, you'll make it 1. Like now you know that it is sorted. Is it clear?
Like it is also like it's like if the array is like 2, 3, 1, and
Okay.
like if it's a 0, like how it can be, like how it can make it sorted, like if
Well,
it's
if it is 2, 3, 1, then you'll have v dot back as -1, right? This is not sorted. So if anyway you'll get a 1 after this point. So it's no.
okay, got it. Thank you.
Okay. So can I show you the implementation? Yes, like in this problem, you could have solved this by looking, like you should have received some idea by getting the idea, like by looking at the test cases, how to solve this. Like you would have got some intuition of using stacks. So I'm using this vector as a stack only, right? But anyways, I'll show you the implementation and then we'll move to the D problem. So first I'm taking string S as input. Then initially f is 1. And if f is 0, then my answer is no, otherwise it's yes. So this is my vector v. So if I'm getting a positive character, like plus character, then first I'll check that my vector is having size. Like you cannot directly do this thing. If you directly do this thing, you'll get a runtime error. Why? Because if there is no character in v, how can you do v dot back? V dot back gives you the last character of your vector. So if you have size and the last character is -1, you'll push -1 in your vector. Otherwise, you'll push 0. Otherwise, if you're getting a minus, then you'll first retrieve the value of last character, then you'll remove it, and if the retrieved value was 1, then and also check that there is still some character, like there is still some value in your vector. Otherwise, if there is no value in your vector, again this thing will give you runtime error. So if there is some value and the last retrieved value was 1, then make your last value as 1 because it's still sorted. Then otherwise, if you're getting 1, you can first check if the size is less than 2, simply continue because there is nothing to do here. But if your v dot back was -1, indicating that the array is not sorted, then your f becomes 0. This is just changing my flag from 1 to 0. Otherwise, I'll change my v dot back to 1. Like if this is not true, I have two cases, 0 and 1, like I said, and I'll make my last value 1. Otherwise, if v dot size is less than 2, then first I'll make f as 0. Why? Because the array is sorted if I have less than 2 elements, and I'll simply, like, I can break here also. But once f is 0, there is not, like, it is never made 1, right? If once f is 0, so I can break here also my loop. Otherwise, if this is not true, I'll check if v dot back is 1. V dot back is 1 if my array is sorted. So if it is sorted, and this is the case when e is 0, so that in that case also f will become 0. Otherwise, I'll make my last character or last element in my vector v as -1. Finally, if f is 1, I'll print yes, otherwise I'll print no. Is it clear? Is it clear? Yes, no, anything? Okay, what about others? Is this thing clear?
Can you explain me the last else part?
This
Last.
thing. Okay.
No, the whole else last.
Okay, this thing. So this thing is you're either getting like 1 if the array was sorted or 0 if the array is not sorted. So 1 means that at this point monocarp is telling you the array is sorted. If the size, like the number of elements that you have in your array is less than 2, indeed it is sorted. So simply continue. Otherwise, if in your vector you have the information that up till this point the array is not sorted, simply mark your flag as 0. Then if this flag wasn't, like the last element in your vector was not -1, either it was a 0 or a 1. 0 indicating that you didn't had any information whether it's sorted or not, and 1 denoting that you had the information that is it's already sorted. So in both of those cases, you can just make your last element as 1. Is it clear? This part, is this part clear?
Yes.
Okay. So now, otherwise, if you're getting e as 0, so this means that monocarp is telling you that the array is not sorted after these, like at this point. So, but if your array is having less than 2 elements, then it is considered to be sorted. So in that case, you can simply make your flag 0. Otherwise, if your, like the last value in your vector is 1, so that meant that at this point the array is indeed sorted, but monocarp is telling you that it's not sorted. So again, make your flag 0. Otherwise, if this is not true, that meant either v dot back is -1 or it's 0. So in any way, like you surely know that the array is not sorted at this point, so that's why you can make v dot back as -1. Is it clear? Is it clear? Yes, no, anything?
Yes, sir.
Okay, so let's go to the next problem. So this is the next problem. In this problem, we are given that we have an array A of length n consisting of positive integers, and we can perform the following operations on this array any number of times. Now, what kind of operations do we apply? So we first choose 3 integers L, R, and X such that L and R, L is less than equals to R, and both of these integers are between 1 and n. Then we multiply every AI with such that I is between L and R by X. So we can choose any integer X. It doesn't have to be positive. So we have to find the minimum number of operations such that A is sorted in strictly increasing order. Like it is not decreasing order, but it is strictly increasing order. So first of all, let me know, what do you think, what is the maximum number of operations in which you can guarantee that the array that you'll get, like let's suppose this is the array, n is equals to 6. So what is the maximum number of operations in which you can guarantee that after multiplying some, like what is the operation L, R, X, you will select I between L and R, and you'll multiply A of I you'll multiply a of I into x, right? So tell me how many operations do you think are required to make, like in worst case, like just give me an upper bound. Okay, actually it's n minus 1, but you can look at that as n also. So why n minus 1? First of all, see, n is clear to everyone, right? N is clear to everyone, right? How is it n? See, first of all, it is n because, see, you multiply this thing maybe by 1, you multiply this by 10 to the power 10, you multiply this by 10 to the power 100, you multiply this by 10 to the power 1000, and like this thing, you keep continuing this because x can, in the problem statement, it's only given that x should be an integer. It's not given that x should be between these two values, right? So if x can be arbitrarily very large, you can multiply it with, like, multiply these numbers with any value, right? So finally, you will have something like maybe something like in 10 to the power 5 here, it's 10 to the power 10 order here, 10 to the power 100 order here. So finally, you'll have this thing. Then you can always make your array in increasing order, strictly increasing order in n operations, right? But now tell me, how did you came with n minus 1? Like anyone can unmute them and let me.
Don't need to multiply the first number.
Yeah, actually, you don't have to multiply this. Why are you multiplying? Like, what is the point of multiplying this? And to be more precise, it's not about this thing. I can look it like this also. Multiply this value. See, initially in the problem statement, it's given to us that each and every element in the array A is between 1 and 10 to the power 9. So that means that the values in initial array are all positive. So I can multiply this with 10 to the power minus 100. Okay, minus 10 to the power 100. I can multiply this with this value, multiply this with 10 to the power 100, multiply this with 10 to the power 10, multiply this with maybe minus 10 to the power 10, and let's say I'm having 5 elements. So I don't have to multiply this with anything, right? These elements will all, this will become very low, this will become also low, this will remain this thing, this will increase, and this will also increase by many times. So finally, it's not always about that I don't need to multiply the first element. It's about keeping one of the elements same, and I'll adjust all the rest of the elements somehow, that keeping this element same and adjusting other elements, I'll get n minus 1 operations, right? Yes, no, anything? So,
Yes.
so there always exists a case, an answer in which one of the elements is unchanged, right?
Yes.
Okay. So now we'll do the same thing, but we'll do it smartly. Like we'll calculate the thing smartly. So we have an array values like this. Let's say for each, like we'll try to keep each element same. Like first this, then this. We'll iterate like this in this direction. We'll try to keep these elements same, and all the elements that have appeared before this element, we'll try to make decrease them something like this, and we'll try to increase all the next elements something like this. So if we, for each point, if we are able to get the number of operations required to do this and this, our problem is solved, right? If we get these two values for each element, let's call this as pref of I, prefix of I, and let's call this as suffix of I. So if for each I, we are getting these two values, prefix of I is nothing but the number of operations required to make all the values in this, like in increasing order, such that this value, that I minus 1 value is less than I, and suffix of I is nothing but to make all of these values in strictly increasing order such that I plus 1th value is more than I. So my answer will be nothing but answer is equals to minimum of answer, comma, prefix of I plus suffix of I. And I will go from 0 to n minus 1, right? Is this thing clear?
Yes.
Okay. So now, if this is clear, how to, now the real problem is how to calculate this prefix of I and suffix of I. So let's first see how to calculate suffix of I. If I have something, okay, let's see, this is my number, like these are my values. This is 0, 1, like these are the values and these are the magnitude. see, once we have calculated prefix of I and suffix of I, the complexity will be O of n, right? I'm just iterating through my array and I'm calculating this result. So the complexity will be O of n. If I have calculated once, I have calculated prefix of I and suffix of I. So that's what I'm calculating now. So first, let's calculate suffix of I. Okay. So suffix of I is nothing but how many operations are required to make the elements more than or equals to, like exactly like in strictly order after this ith element. Like let's say, so I had something like this. These are the magnitudes. So see, for this thing, suffix of I is 0. For this thing, since the very next element is less than 0, so this you have to do at least one operation, multiply this thing by some value, right? Then for this is more than this. So the number of operations that were required for this are also valid for this. So one operation is required. Then this value is less than this thing. So you'll have to apply two operations. Why? One for making this high and then another one for making this high, right? So one operation for this, like this is 0, 1, 2, 3, 4, 5. So these are my I values, indices values, and these are my magnitude. Magnitude is nothing but, by magnitude, I mean array like value at I. So if these are my values, A of I. So here, if my value was this thing, the previous value is more, then I will have to do one operation if I want the next value to be more than this. If the value is less than the next value, then I'll simply copy this value here because the number of operations remain same. Again, the value of this thing is more than the next value, so the number of operations will increase by 1. 1 plus 1, 2. Now the operations will be 3, and here the operations will be 4. If I have something down here, then the operations will remain 4. Is this thing making sense? Yes, no. Why? Because each time when this value is more than this value, I have to increase this also by a factor, right? Once I increase this by a factor, all the operations that were like that you were doing on this value, that we're doing for this value, they still are required. Why? How, like this doesn't change anything, right? This value is now here, and all the operations that were earlier being performed are still needed to be performed. So okay, so everybody, like calculating suffix of I is clear to everyone, right? How to calculate suffix of I. Can anyone just unmute and let me know? Is it clear? Like you all have been okay. So now let's try to calculate prefix of I. So prefix of I is a little bit like it's more trickier to calculate suffix prefix of I. Why? Because see, let's again make this. Let's say these are my magnitude and these are my indices. So let's say my array values are something like this. Okay, how to calculate? See, for this, my prefix of I will be 0. Why? Because before this there is no element. Before this, can anyone tell me what is my prefix of I here? 0. Why? Because the previous value is already in strictly increasing order. If you look before this, right? What about here? What should be? Now, can anyone tell me what should be the value here?
1.
Okay, how can you do this in 1? Anyone? Like, can you tell me one operation after this? You can make these two elements less than this element and in increasing order also. How will you do this? You have to multiply these two values. You cannot change this value. You have to multiply these two only. How will you do? See, let me tell you. See, if you can only multiply, you cannot divide. You can only, like, the only option to decrease these values is to multiply these by negative values, right? And if this value is more than this value is like this value is more than this value, then if you multiply this with any negative number, negative integer, this value will finally come here and this value will finally come here, right? Right? Yes, no, anything?
Yes.
So this is not increasing order. You'll have to do two operations here. So for this, you'll have to do two operations. For this again, how many operations do you think you'll have to do? two operations are sufficient. Why? You club these two. If you club these two, you first multiply this with a very huge negative number. This will shift down. Then you multiply this with some negative number. So this will come here and this will come here. These two are clubbed together. These two are getting multiplied together. So basically in this, if when you're calculating prefix sum, you'll have to calculate how many times you're getting these jumps. If you're getting these decreasing values, your value will always be 2 only. Why? Because you can club these together. Then when you come here, you'll get 3. Here 3. Here you'll get a 4, 4, 4, and 4. Is this thing making sense? Why? Because when you jump from here to here, okay, it's actually, is this thing making sense? In prefix of I. Because you can club these things and these things will, if you multiplied by a negative number, these things will already come like this. If these are in decreasing order, if you multiply these values by a negative number, they will come in increasing order, right? Take for example 3, 2, 1. Multiply these values by -1. What you are getting? You're getting -3, -2, and -1. So you're already getting these values in increasing order. So that's why you can club these together. So the point is, if while calculating prefix sum, if you have something like this, you can club these values together, then club these values together, and then club these values together. So this, for this, you have to apply 0. You have to apply how many operations for this? For this, you have to apply 0 operations. For this, you'll have to apply 1 operation. Why? Because the previous value is more. For this, you have to apply just 1 operation. Why? Because by applying 1 operation, you can change both of these together. You'll make, let's say you have 3 here, 2 here, and 1 here. So you can multiply these. You have 3 here, 2 here, and 1 here. So for operation of this, like the number of operations, pref of I for this is 0. Pref of I for this is 1. Why? Because you have to change this thing, right? You'll have to multiply 1. Why? Because you can club these two together. Now, if you multiply both of these with -1, this will become -3 and this will become -2. Is this thing clear? Similarly here. So number of operations for this is 0, 1, 1, 2, 2, 2, 2, 3, 3, 3. So that's why it is a little trickier when you're calculating pref of I. Now there is also one more thing. See, like suffix of I was easy to calculate. You just have to check whether the current element is more than or equals to the next element. But there is one more thing in this prefix of I. See, it's not about only decreasing element. You want strictly increasing. So if you want strictly increasing, if you have two elements which are same, right? Then also you'll have to make one operation here. Why? Because you have to decrease this. Are you getting my point? Right? If you have 2, 2, 2,
Yes.
if you have elements same, then also you'll have to like, right? If you have 2, 2, 2 like this, then if you have all the 3 elements same, then also number of operations here is 1, pref of I, and pref of I here will be 2. You'll have to apply 2 operations here, not 1. You cannot make in one operation, you cannot make both of these in strictly increasing order. So basically you only club those elements which are in decreasing order, strictly in decreasing order, then only you can club those elements. So let me show you the implementation. So first I'm taking n as input, then I'm taking array A as input. So OK means that initially the array which is given to me is in strictly increasing order only. So in that case, I can simply print, like I'll check if all the values I are more than A of I minus 1, then I can simply print 0 because none of the operations are required, right? Yes, no, anything? Okay.
Lag
Yes.
Okay.
Yes.
So then I have these vectors, suffix and prefix. So like I said, splitting suffix of I is really easy. You just go in reverse direction and you check if the current element is more than or equals to the previous, like the next element, like we did here. So if, like here, if the current element is more than the next element, you'll add 1. Otherwise, you'll simply take the next value. If this is more than the next element, you'll add 1. So this is being done here. Suffix of I will be suffix of I plus 1 plus whether or not this element is more than the next element or not. More than equals to, because you want strictly increasing, not simply increasing, right? Now this is suffix of I. Now how to calculate prefix of I? So initially, the prefix of 0 will be 0 only, but prefix of 1 depends on either, like, if this value, if a of I is more than a of I minus 1. So if you have something like this, if this prefix of I is more than prefix of I minus 1, then you'll simply take the previous value, right? So then I'll simply take the previous value. Otherwise, I'll take x. So what is x now? X is the number of places where I'm getting this thing, where a of I is more than equals to a of I minus 1. So a of I is more than a of I minus 1. So these are those jumps. These are those jumps, right? Like, is someone not muted? Okay.
Yes.
So basically, these are those jumps, right? So here, my value will increase by 1. My value will increase by 1. You can say that this is your x. This 2 is your x. So this remains 2. But when your a of I turns out to be, like, a of I turns out to be more than a of I minus 1, or even same, like I said, if even it's same, then you'll increase your x by 1. You'll have to make one more operation now. So that's why if a of I is more than equals to a of I minus 1, then you'll increase your x by 1. Finally, your answer is nothing but minimum of pref of I plus suff of I over all the I from 0 to n. Is it clear? Like, number of operations required to make the prefix of I.
ये suffix में कैसे ऐड कर रहे हैं?
Okay, like, this simply means you are not adding, you are just calculating. Okay, you're just adding. If this is your array, you keep this element, whatever it is, and you try to find how many operations are required to make these elements in strictly increasing order and less than this value. And for this, suffix of I is giving you how many operations are required to make these elements, these 3 elements, in strictly increasing order and more than this element. So this is given to you by prefix of I, and this is given to you by suffix of I. So if you add both of these operations, you will get, if you decided to keep this element unchanged, then what is the number of operations required? So you will try to check for each of these n elements, and finally your answer will be minimum of pref of I plus suff of I. Is it okay?
What if every element is changed?
No. This I explained in beginning only. There is no, like, see, you can always get your answer in n minus 1 operations. So why will you change each and every element to get your answer in O of n? Like, why will you try to change each element and get your answer as n?
Okay.
Because how, like I explained this thing, right? There is no, see, if you have to change each, like, you can anyway get your answer in n operations. But why to change this thing when you can change this by, let's say, you multiplied this by a factor of 10 to the power 10, multiply this by a factor of 10 to the power 100, and like this thing, like, because you have to multiply by integers, and there is no limit or bound on which, like, what is the maximum integer that you can take. So you can always get your answer in n minus 1 operations. So by that sense, one of the elements will always, like, you can always keep one of the elements unchanged. Is it okay?
Yes.
Okay.
I have one question.
Yes.
Like for the prefix, if we try to make the prefix strictly decreasing, and like suppose we have p number of steps for this, and then
Okay.
we did that, like we need p plus one number of steps to make it strictly increasing such that it is less than the value at I.
Yes.
So like the both numbers should be same, isn't it?
Which number should be same?
Like suppose for like we have an array, and like in the array we are at ith position,
Okay, we
and
have an array and we are at the ith position. Okay.
so we know the number of steps to make the array before ith position
Okay.
strictly decreasing.
Okay, we know this thing. Okay.
So we can say that, okay, if it is strictly decreasing, we can multiply it by some negative integer and it will become.
Yes, if there are like, let's say these three, let's say these are the three sub arrays in which like this is also decreasing, this is also decreasing, and this is also decreasing. So you can do this in three operations. You can change this to strictly increasing and less than I in three operations. Yes, then
So like then we can multiply it with some negative integer and it
yes,
will be increasing
yes,
and less than I.
yes,
So
yes. Multiply this with 10 to the power minus 100. Multiply this with 10 to the power minus 50, and multiply this with 10 to the power not minus 50, minus 10 to the power 50. Like you get the idea, right? You can always do this. Yes,
so
then
it will be it is your no, like it will be same uh, the number will be same for it will be equal to the number of steps such that we can make it increasing as and less than I.
yes, for this part you'll get that.
Okay, thank you.
Okay, okay, okay. Like in case you are still having confusion,
Suppose like
don't. Yes, yes,
yeah, if we are decreasing, we need to add one, isn't it?
yes. Yes, yes, yes. If like after this point, you get to a point which is more than. See, if a of I is more than a of I minus one, then you'll have one more new strip now. Like you're calling these things strip, right?
Yes.
Yes, yes. So this is nothing but x. So if this is more than or equals to this, then you'll increase your x by one. So now
So,
one more operation is required.
okay. So
Is it
there is no edge case that can struck in this way.
No, no, no. Like it shouldn't be there. Right? My solution has passed, but okay. In case my solution fails for some like after like there is a 12 hour, uh,
So
there is
my
that.
third test. So I was thinking maybe I'm missing some edge case or something like this. I was doing in this way. The suffix was same. For prefix, I was doing this.
Okay,
Okay. Thank you.
okay, okay, no problem. So that's it. So I think if there is no other doubt, we can stop. And in case if you are still having doubt, like after the system testing is completed, and that right now I think the preliminary hacking phase is going on. So after that gets finished, you can raise a query. Maybe like if I'm available, I take that query. Otherwise, if other mentors are there, they'll surely help you.
Why
So
not before system testing?
no, you can raise it before also, but like this student just asked me before, like he was not sure that my solution will work or not completely. If it has passed all the system tests, then it will surely work. Like
Like
I'm
I
pretty
wasn't
sure that my
doubtful
solution
about,
will work.
I wasn't doubtful about your suggestion.
Okay,
Mine
okay,
was
okay.
but my failed on three. So maybe I have been doing something wrong in my implementation.
Yes, 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 it's possible. So yeah, in that case also, just raise a query. Okay.
Okay. Thank you.
Yes, yes, yes. Okay. So thanks for joining and bye.